Hi, how's it going? Today we're just going to do kind of a chill session, just a jazzy kind of chill session. What I'm going to do is I'm looking at software rendering. There's kind of a few reasons we'd want to do that. Number one is we might just enjoy the minimalism of throwing away frameworks and just doing things ourselves. We might enjoy the challenge of trying to get the most performance out of our system. We might be looking at something which is sometimes easier to do in software, or at least a bit more straightforward. I wouldn't say it's easier, but it's something that we can implement in software, play around with, have fun with it. So if you search for Raycasting tutorials, this is my motivation. We have this tutorial series here by Lode van der Veen, which is really, really good. It's awesome. And you know, I think I've used this code before in my OpenGL raycasting, but what if we want to do this in software? Other example is, I'll just bring this up. We might have a book like this one, which kind of talks about, you know, it's pretty old, talks about graphics algorithms in kind of low-level terms. You might want, where are we? One of these, right? You might want a library that has a function to set single pixels and do things like for fun. And yeah, all of that is coming around to this. So if we look down at this tutorial, this is all based around this library here, which Lode van der Veen wrote, called QuickCG, Quick Computer Graphics. But this library is written for SDL1. So I was working on this for fun, and I got about a quarter of the way through, I guess, and I thought, hey, this would be a great thing to look at. I've actually rewritten this a number of times, but I just want to go through and I'm rewriting it for SDL2. That's it. Basically, it's like a code review. Looking at other people's code is very good, it's very fun, and helps us to learn how to do things. So I've downloaded this QuickCG.cpp and .h. We just get that just by searching. And we can just click those files and download them. The other thing that we will need for this tutorial to follow along, I'll be posting code, not at the moment because I don't have my my stuff with me, but that will be coming. Where are we? We want to have an SDL environment, C++ SDL environment. The best series for setting that up will be this one, lazyfoo.net. If you're working on Mac, which I am at the moment, there is a tutorial video which I'll link down below for setting SDL2 up on Mac. It's yeah, pretty good, very good video. But yeah, I'll just show you the environment that I'm working with. So from that video, which I'll link down below, we have this SDL2 starter. I'm just going to rename this to, right, because I'm porting this library over. And just to start with, I'll open this up and show you what we've got super quickly. So we have this make file and then build. Let's get rid of this for the moment. Doesn't matter. Build and release, and I'll just open this up. Okay, so the make file is defined here. We are just doing a G++ build. And what I want to do, I'm just going to change this, my source files, I'm going to do a wildcard search for all of the CPP and all of the header files as well. Okay, and I'm including SDL here. And yeah, like I said, it's not really my place to explain, so run through the, what am I thinking, the video that I'll link down below, and that will explain how to kind of get this set up on a Mac, or follow your own process, Visual Studio, C++, on Windows, whatever you want to do. Okay, cool. So then how do we kind of get this running? Well, going to be very imaginative and just do it all in terminal. So we'll go was it that hard? Okay, anyway, so what do I want to do? I want to run make. Okay, fair enough. And then I'll just make a new tab. And as we can see, that executable has been made. So then we'll just go run play. And it says nothing, which is good because the only print statement here would be in the error case. So the point is I'm just demonstrating how we kind of set up our environment, you know, run things, build things and run them in the terminal. Obviously there are much more efficient, or much more streamlined ways of doing that. In the video linked down below, there's a way to hook it up to this build and run button. Didn't work for me. It's kind of janky. So I'm just going to leave things as they are. I'm happy with this. So what I really want to get to is porting these files. So we'll go to, downloaded them. Okay, so we have QuickCG, header, and CPP. I'm just going to paste those into my source folder. Okay, cool. So I'm actually going to leave this because a lot of this will just be editing the code pretty much and removing the errors. So of course we're doing SDL2 now. I'll just give that a second and that is basically fine. That's weird. How can there possibly be an error in the comment? Possibly just give that a second. Is it an include error here? Throwing off the other file. Yes, it is. Ha, that's funny. Okay. So I'll just get this out of the way. That's fine, who cares? Okay, so if we look through this header file, we have a bunch of basically function declarations, and there's not going to be an error with these function declarations. They should be okay. I believe the issue is in the implementation. So we'll just scroll through until we see something wrong. So the first thing I see is we have a screen, and by the way, this is all within a namespace, QuickCG, and this screen is kind of a namespace variable, so it's scoped to the namespace. We have this SDL surface pointer, but there's no SDLSetVideoMode. So what I'll do is I'll just go over to this, where are we? Let's open this up again. Yeah, this migration guide on the SDL wiki, and just search for, yeah, SDLSetVideoMode is gone. So this is to kind of unify SDL2 with more next generation graphics APIs, which have separate kind of window things, swap chains and things, and then separate renderer objects. So what we'll do is, first of all, we'll create a window, and then we'll create a renderer to render the window, and then we'll have some other things. So we'll go back here and find where we were. Okay, so we'll have write an imaginative comment. And then, where are we? We will have the, well, if we look at the migration guide down below, come on, okay. So if your game just wants to get fully rendered frames to the screen, so this is kind of what we want, right? To get maximum performance, we want to reduce the number of blit operations. And so we'll have this texture, which covers the whole screen, and we'll have a pixel of colors, sorry, an array of colors, and we'll blit one to the other. So what we'll have is, we've got the renderer, then we'll have we'll put that there. There we go. And we're also going to have an array of pixels. Okay, so the color buffer is what we can touch, and that gets sent to the texture, and the renderer sends the texture to the window. It's a little bit weird, but it does work, I hope. So the first thing we see is all of this nonsense, and I mean, it's fine, it's good, but I'm just going to simplify this a little bit. So what do we have? We have whether we want to be full screen or not, and if we're okay, let's not worry about the full screen checks. That'll be one simplification that we'll make. We'll say okay, SDL create window. We want the title, the X, Y, the height, and all of that. So what do we have? The title of the window is going to be, if we look here, we have this text. So we'll put that in. The X and Y are the position of the window. We're just going to set that to undefined, so it just automatically pops up wherever we want. Now for the width and height, we have those. For the flags such as, do we want to, hidden, resizable, maximized, minimized, do things? I'm just going to say no, 0, and that'll just more or less create the default thing. Now we have an error here because we've got a standard string. We want to get it to a constant character pointer, which is achieved with the cstring function. gonna that. Okay, if window equals null. Okay, and down below we have set caption. We can just get rid of that because that's already done in this argument here. We don't need to worry about that. And then we have this SDL enable Unicode. So if we search on the migration guide, SDL enable Unicode is gone. So long story short, we actually don't need that anymore. So we can just get rid of that completely. But clearly we have a few other things we want to set up. We want to create the renderer. SDL create renderer, and we have, come on. Maybe if I spelt it right, it would help the IntelliSense. Okay, pass in a window, an index, and flags. So we'll pass in a window. Yep, okay. The index, I think if we pass in -1, it'll just choose one automatically. And flags, we're going to put no flags in there. And we can check this because we go up here. Okay, yep. So we have create renderer, index of the rendering driver to initialize, or -1 to just get the first one. Flags 0, or use these SDL render flags. We go into the SDL render flags. Let's try this actually. For now, why not? Let's just see what we can get away with. And we'll find out if it's not supported. Side note, I honestly think none of this will be supported, and I'll have to run this on my Windows computer. Okay, so then we need the texture. Okay, so we have the renderer, the format, there we go. No, not that one. So what this is we've got everything packed together in a 32-bit integer, alpha, red, green, and blue in that order, taking 8 bytes each. Okay. Then access is let me just double check that. There's an example here on the guide. Ah, that's right, streaming. Right, width, so that is W, and height is H. Okay, then we also need to allocate space for the color buffer. Okay, so we allocate memory, given number of pixels, and about 4 bytes per pixel. So that's just telling the number of bytes we want to allocate, and this returns as a void pointer, so we cast it back to an unsigned integer 32 pointer. Okay, so let me just be 1 second. I'm just going to explain the format that I'm going for here. Okay, so basically what we have is we have the screen. There we go, we have the screen. And the screen has some width and some height. And we need to kind of represent all the pixels on the screen. Now, what I'm going to do is we're going to use a flat representation. So let's say this is row 1, row 2, and so on. Then the layout in memory is something like this. We have row 1, row 2. Now row 1 goes left to right, and that's what we have here. But once we reach, so what, this is 0. Once we reach position, so 0 to W minus 1 is still inside row 1. Once we reach position W, width, that's skipping over to the next row. Then we have 2W minus 1, and then 2W will be the start of the third row, and so on and so forth. So what we've got is, just remember that a pointer is an array, basically, because it's a pointer to a spot in memory which is reserved for a number of these integers, right? But what I really want to look at now is we have a position. I won't do that. Okay, so say we have a two-dimensional XY position. The position of that in the buffer will be x plus width times height, because every time height jumps down by 1, we jump across by W pixels. Does that make sense? Hopefully that makes sense. Anyway, that's what I'm doing here. And then the other thing I was going to say is, because we have a 32-bit integer representing a 4-dimensional number, then we have what? Alpha, red, green, blue in this case. And the operation to do this is we have, we take the alpha component, we shift that across by 24 bits, and then we add the red component shifted across by 16 bits. A little bit messy, but let's start with the blue. So the blue will be a number between 0 and 255. So when we add that in, that just packs the least significant byte with the blue number. Then when we take the green number, that'll be 1 byte, that'll be 8 bits. We shift it left by 8 bits. That makes it, 250 times larger. And then when we add that to the integer, that packs the second least significant bit with the green component, and so on with the red. We shift that across. Okay, so what are we doing? 16 bits is 2 bytes, so we shift it to the left by 2 bytes and pack it into the integer, and same thing with the alpha. Then what we could do to reconstruct the other components is shift to the left. Shift to the right, sorry. But I'll stop rambling. As you'll see in the implementation, SDL has a way to do this automatically. Anyway, so on with the show. I just wanted to kind of talk a little bit about the memory layout and things that we're using. So we have this lock screen, lock and unlock. I don't know, I'm just going to get rid of that. I'm not really sure what that does, which means it's a great idea to yeah, but anyway, who cares? Okay, so then we have this function. So basically what I'm doing is I'm just going to go through from top to bottom, find errors and fix them. importing this over to the new library. So SDL update rectangle kind of does the same thing as SDL flip, and we can kind of see that here, right? So what we're doing, or what do we do when we render the screen? Essentially, we want to take our renderer, clear the screen, and then copy the texture. Oh yeah, of course, that's the, yeah. Copy the texture representing the screen, and then present that. Present that for viewing. I'm just going to check this. What do we have here? Let's draw buffer. Draws a buffer of pixels to the screen. Well, should probably do that. So there's this, we have SDL update texture. So just before I replace all this, what are we doing? Well, what we're doing is we are basically getting the screen's pixels and putting that into this buffer pointer here. Then we're looping through everything in the looping through every position on the screen, and we're copying from the buffer into the buffer pointer, and then this incrementation kind of steps to the next pixel in the buffer pointer. Do you know what I mean? So the XY is accessing within the buffer that we want to copy over. So this is like draw a buffer to a thing. But I think I'm actually going to go with this. And what are we doing? We're updating. Okay. So take screen. We will take buffer. Now, it's just being slow. So what we have here is, a pointer to the pixels and pitch. Okay, so the pitch, it says here, is the number of bytes in a row of pixel data. So that's simple enough. We'll take the width of the screen times the number of bytes in an unsigned integer, and that should be it. Okay, yeah, that works. Cool. So what I'm going to do is I'm going to use this up above. So we'll say now this is a little bit of overkill, right? Making another function just to do a one-liner, but hopefully the compiler will inline it for us, so shouldn't be an issue. Let me just explain that. There's a bit of extra overhead involved in calling a function, but luckily compilers are pretty good at optimizing, unless you put them in debug mode like I did, but basically it's fine. We can always just copy paste the one-liner, right? So what are we doing here? We're clearing a screen. Okay, so essentially what we want to do is we want to basically we want to take so I'm going to take an alpha component of full, so 255. Take the red component, shift it over by 16. am I doing? RGB. Okay, so this packs the red, green, blue plus an alpha into a pixel, and then what we want to do is basically loop through. So we'll say, but we can take advantage of the flat memory layout, so we can say for there we go. Now the reason I'm using this color SDL variable is I found down below that its load is using color SDL to represent the 32-bit integer. Reason for that naming convention is that SDL represents its colors as 32-bit integers. Fair enough. We might want to have our own individual component representation because we might want to do tinting and things like that. It's a little trickier to, it's easier to work with it this way. Okay, so we're just looping through, setting everything good. Now, pixel sets, we're setting at a certain position. Now, the issue here is that SDL map RGB is okay. It's just that screen is a texture and it doesn't, this isn't really the way to get the format. So what we'll do is, I was looking at this before, we have this, where are we? Query texture. So, right. So let's try this. Let's say I'm just checking this again. Okay, so we want this constant SDL pixel format. Okay, so go SDL. Okay, so we want to get the color buffer format, and we'll do that by querying the texture. And here's what we want to do. We want to pass in the color buffer format and populate that. For access, we don't care, because we're not checking these other things. We're not checking the access mode. We're not checking the width or the height. That's fine. Now it does complain here, and it complains here that, hey, actually, let me pass this in. Okay, so that's fine. We do need this color buffer format thing to be passed in, but query texture doesn't like it. And the reason is, if we click into here, no. It's this SDL pixel format. It's actually kind of a structure, so it has all these things inside it. And what we want is the unsigned 32-bit integer called format. So we can, when we run this, what we're actually populating is the format within that structure. So that passes through, good. And now we don't, so what we've got here is we've got this buffer pointer and we are accessing the screen pixels, and then we're incrementing it by this amount. So this is really the same. This is really the same as writing screen pixels, that, which is really what we want. And then what we're doing here is we're kind of dereferencing that pointer and setting it equal to this. So again, this is really equivalent to doing this. Okay. It's just being a bit fancy with the pointer arithmetic. And this kind of like almost gets us there. All we need to do is replace this and say, right. I mean, why complicate it? Okay, cool. So now we have pixel get. And again, so what are we doing? We've got this color SDL equals that, and really we're just doing the opposite, right? So we're just accessing based on X and Y, right? Because color buffer is storing a bunch of integers, and we can just get rid of all of this. And okay, so get that. We need to do the same sort of trick that we did before, and that's okay because we can just copy this. And yeah, that should work. That should be good. Now, just for completeness, don't be too intimidated by this, because another way we could do this is we could say color RGB equals. I'm just going to write this out. So we have just if we're looking at hexadecimal, it'd be 8 bits there, and then red, green, blue. Okay, so if we take color SDL and then we shift it down by 24 bits, then that will, yeah, of course we need to, sorry, we don't have a, we just have a red, green, blue. Okay, so say we want the red, then we'll shift this down by 16 bits, and then we want to just capture the lower byte, so 2 bits, 2 digits in hexadecimal. And this works, but it only works for this 8-bit ARGB format. And we want to make the library as general as possible, so that's why we're using this get RGB sort of thing. It just populates these fields. Okay, right, draw a buffer to pixels to the screen, that is fine. Get screen buffer. Interesting. Now, I'm going to just change the return type here just for consistency. Somehow it just feels right to have, yeah. Okay. That's fine, we don't need that. We already have the color buffer in memory. Now, resize. Let's do this. Actually, why do we need to resize? Well, okay, let's not look into it too much. Let's just, okay, how do we do this? We would reallocate, basically. So in other words, the way reallocate works is we take a pointer and then we take a new size for it, and the library attempts to kind of keep them at the same size, but if need be, the library tries to keep it in the same location and just add more memory onto that, but if need be, it will allocate a new slot in memory and copy everything over there. Okay, so we're just looping through, and really what we've got is we are taking same stuff and just copying this over. Okay. Good, so we test if something's on the screen. Poll event. It's probably fine, I guess. Okay, get key state. So again, we go to the migration guide. Okay, so we have SDL get key state has been renamed to SDL get keyboard state. Okay, so no problem. Now it complains that this one is returning a constant pointer, and this one is just a pointer. So we can go back up to the top and go change that to a constant, and that is fixed. But there's a bit of a subtlety here. It says the returned array should now be indexed by SDL ScanCode values instead of SDL keysim values. So if we go to SDL ScanCode, for each of these, we have the ScanCode values and the keycode values. Now if we look back here, we're going SDLK escape, and SDLK escape looks like it's in the keycode thing. So we want to shift this over. We want to go to SDL ScanCode escape. And with that in mind, we also want to just check where are we using SDLK. See, it's down here as well, so just fix that. And nowhere else. But then let's leave it for now. Let's leave it for now. I'm happy with that. Okay. That is looking good. Yep, that's fine. And again, okay. So this read keys function should be going, calling that one. Yeah, mouse state and all. There's just, where were we? I just want to check this. So see, we have key down and key pressed. I just want to change this, make it a little safer. I just want to ensure that when we access in keys, we're enforcing the SDL ScanCode type. And then if we pop back over to the header, to the definition of these, we want to enforce it here as well. So yeah, like this is a fun exercise. I'm having fun. Okay. What's the next one? Right, draw a horizontal line. So again, we'll just go through the same stuff that we did before. Yeah, I'm not going to worry about this. So what are we doing? We're drawing a horizontal line, which means we're looping between two x bounds. Fair enough. Well, let's simply access it there, and yeah, that looks good. I'm probably going to refactor this in a second because I'm starting to realize exactly how ridiculous it is of me to be querying this every function call instead of just storing it. But go with this for now. So if we can see here, when we draw a horizontal line, that stuff is contiguous in memory. You're stepping from one pixel to the next pixel. You only have to step up by one. When we draw a vertical line, we should really be stepping up by 640 because you want to go one pixel down, which is the same as 640 pixels across, right? If your color buffer has a flat layout. But we can also basically do the same thing simply by the same pointer arithmetic here. Right, because x is given to us, y is looping, and this is the correct formula to access the XY pixel. Okay. This one's okay. No errors here because we are, where are we? Because we're pixel setting, so that's fine. Should be fine. Yep, same, no issues here. Okay, I think it's time for us to just change this over. So I'll go back to the creation code. So we want to store also a pointer to the format of the color buffer. And what we'll do is we'll query store that in there. What am I doing? What am I even doing? Okay. Of course, this is a pointer, so we access that element there, and then we pass an address of it. There we go. Okay, I think that's good. Okay, so what I'm going to do is I'm just going to, where are we? Okay, I'm just going to go. Actually, we should probably do that the other way, shouldn't we? Get the cache adjacency, so it's faster to draw horizontal lines. As a matter of fact, we can take advantage of that and use the horizontal line function. don't need to worry about these. Let's see, we'll say right, so we'll take y1 as the kind of the upper height and y2 as the lower height. And if that's the wrong way around, then we'll just flip it and then we'll pretend like it does work that way. And then we'll loop between one and the other. And what we'll do is we'll draw a horizontal line at y between x1 and x2, just passing that color. Yep, that's good. Okay. Right, so here we have some various color conversions, and then I think we just go down here and then we're looking at the text things. Okay, so get input character, so we need to get the Unicode. Okay, so this section here, enable Unicode is gone, so is SDL KeySim's Unicode field. Fun, fun, fun. So what are we doing? If event KeySim Yeah, let's leave that. So what are we doing? Well, we're getting a character from pressing a key. That'd be cool, that'd be good, but I'm not going to use that for now, so we'll just leave that. Yeah, so string encoding, decoding. I'll leave that there. It's not giving errors, but this sort of stuff. Yeah, this sort of stuff, I'll leave it for now. Maybe add that in. Maybe I'll add that in at a later point, but it's fine. Okay, so we have a list of things, a vector. And idat is seems to be a vector as well. Okay. So this is what we call it's got rid of some symbols and it said it was okay. This is what we call never call this function ever, because I don't know, all I did was fix the error. I don't know if I broke the function. What I'm going to do, I'm just going to leave this for now. And this will be one of those, yeah. Okay, seems to, oh yeah, now that works. Okay. Okay, right. So that was just a quick little run through of porting over the library. I guess I still have a few things to learn. Not sure why that insert was causing an error at the end. I'll have to look into that. Anyway, that'll be it.